number-based conversion. Here we see that how to convert from one number system to another number system, or if a number is unknown, how we'll find that number, and sometimes if radix is unknown, how we'll find that radix, what type of the question they're going to ask. So here we'll have discussion that how decimal number is going to help us to find the unknown number or unknown radix for any other number system. So still, if you didn't subscribe our channel, please subscribe it, share with your friends, write your comments, like it. So now, suppose earlier what we have seen, if you'll expand any number system with their radix, what we are going to get? We are going to get the decimal number. Suppose, for example, if you are taking here, we have 0, 0, 1, 1. This is we are writing as the octal number. Okay, this is the, even you see that 0, 0, 1, 1 is that, but is the octal number. Since in the octal already we have seen that coefficient are 0 to 7. Okay, and here base is 8. So when we'll expand this one, so how we are going to expand, we'll mark this one 0, this is 1, 2, 3. We are trying for easy method. So now here what is the value here? That digit is 0. So we'll write 0 into 8, radix is 8, and this position value is 3. So we'll write 3. Okay. So finally, second one, again digit is 0. So we'll write the 0 multiplied by radix. Again here, what we have marked 2. So it will be exponent 2 plus. Now we'll take this one. So we have 1 plus radix is 8. And here this position is at 1 plus, again next value is what here? G1. So 1 into 8, and this we are starting counting from 0. So 8 to the power 0. So now in this, if you simplify, this term is going to become 0. Again, this term is also going to become 0. Third term is going to become 8. And fourth term is going to become 1. So this is going to be equivalent to 9. And this is what? Decimal number. Similarly, if we go for any binary number, so suppose we are taking 1, 0, 0, 1, this radix is 2. Okay. So similar counting 0, 1, 2, 3 from LSB to MSB. So this right side bit is called as the LSB, least significant bit. Left side bit is called as the MSB, that is the most significant bit. So here radix is 2. So this digit is here 1. We have 1 into to the power 3 plus, next we have 0, 0 into to the power 2 plus, again we have 0, so 0 into to the power 1 plus, and last one we have 1, so 1 into to the power 0. So finally, this first one value is what here? 8. Second term 0. Third term 0. Fourth term value is what? 1. To the power 0 is 1. Multiplied by 1, we have 1. So this is also 9. Okay. So that is the base 10. So two number is said to be equivalent. Okay. If their decimal equivalent is going to be equal. So here 0, 0, 1, 1 with radix 8 is equal to the 1, 0, 0, 1 with radix 2. Since both number decimal value we have getting the same. Okay. So this is the concept. Two numbers are said to be equal if their decimal number is going to be same. Now we'll see the conversion from the decimal to another radix. Okay. From the decimal. So decimal means that coefficients. What are the coefficient for the decimal? That is the 0 to 9. So we'll have decimal number. Okay. Decimal number to another different radix. To different radix. How we are going to obtain? So to obtain the different radix, so here in case of decimal, if you see that we have two different parts is there. One is the integer, one is the fraction. So first we are going to take example for the integer. How we'll convert integer value into the another number system. So here, suppose for example, we are going to take another number. If you'll have a value, if talking about, suppose we are taking 27. Now this 27, okay, is the decimal value. We have to convert this one into the binary. Okay, so like we have 27, radix is 10, we have to get its binary equivalent. Okay, so here this is the unknown. So this process is easy. So the given integer should be divided by the radix. Okay, after dividing by radix, you will get the new quotient and remainder. Again, we'll divide the new quotient by the same radix until that quotient is lesser than radix. So here, what is our radix? Radix is 2. So we are going to divide with 2. So what we'll have here, this is the 1, then we have 3, the remainder is going to become 1. So now our new quotient is what here? 13. So again we'll divide by 2. So what we'll have here? 6. Again remainder is 1. So now new quotient is 6, which is greater than 2. So we'll again divide 2, 3 times is 6, remainder is 0. Again, we are going to divide with 2. So we're getting 1 times 2. The remainder is going to become 0. So now here what you are seeing, that last quotient is less than 2. Okay. So now we can't divide further. So how we are going to write? We'll write the last quotient followed by the remainders. So from the bottom to top, we are going to write. So finally, this 27, which having radix as 10 is going to be 1. We are writing this one. Again, next one. Then you have 0, 0. Again, 1, 1. This is the binary equivalent of the given integer. Similarly, if you see that for the fraction part also we can obtain. So integer, what we have done? We are dividing by radix. Here we are trying to convert into binary forms. That's why we are dividing by 2. Now, if you have to, fraction part is also there. Always integer will not be there. Maybe we have integer with fraction, or sometimes only fraction is there. So like we have 0.6875. This is the base is 10. We have to find its binary equivalent. Okay. So finally, what we are going to do in this case, first, what is the concept now? That fractions should be multiplied by the radix. In which radix you are going to convert. Okay, so this fraction will be multiplied by the radix. And after multiplication, if integer part we are going to get, or whatever integer is available, that integer will write separately. And again, we'll take the new fraction, and that new fraction will be multiplied by this radix in which you are trying to convert. And again, what is the new integer that we are going to write? And again, we'll take the new fraction. So this part should be completed until fraction is not going to become 0. Okay, if it is the finite number. If after 5, 6 iteration also fraction part is not going to become 0, then after that we can write dot dot dot. So here we have 0.6875. We want to convert into binary number. So we are multiplying by 2. So once we multiply by 2, what we are going to obtain? 1.3750. So now what is the integer here? 1. So this integer should be written separately. Now what is the new fraction? 0.3750. So this 0.3750 is being multiplied by the radix 2. Since we are converting to binary, again we multiply, we have 0.7500. Now integer is 0, so this is written separately. Now again we have 0.7500 new fraction multiplied by 2. What we have here, this is going to become 1.5. So new integer is 1, it should be written separately. Now new fraction is 0.5, so multiplied by 2, what we are going to obtain? 1.0. So new integer is 1 and fraction becomes 0. So that's why we'll stop here. Since again, if you're multiplying this fraction with radix, value is going to be 0. Okay, so once fraction becomes 0, we'll stop here, and this will be written from the top to bottom. So its value is 0.1011. Okay, radix 2. So we are writing top to bottom in fraction. In integer, we are writing from the bottom to top. So here first last quotient followed by the remainder. This is the quotient, these are the remainders. And here we have, this is the integer. Okay. So this is the basic concept how we are going to convert any number system to the any number systems. And if you are able to obtain decimal numbers, then from decimal we can convert to the any other number system. Later we see that how we can easily do for the another number system if you have apart from the decimal and we want to convert in the new system like we have octal to binary, binary to octal, hexadecimal to like binary to hexadecimal. So these all we are going to see here. Okay, how we can do this conversion, okay, easily. But in the examination, what they're going to ask you, either this number they're going to ask, so it is easy since radix is noun. If radix is not noun, then it is going to be little difficult. Okay. So an example we are going to see if radix is not given, then how we are able to find. So here most popular radix, we are talking about 10, 2, 4, 8, 16, 8, 4, we are not talking, 8 and 16. But in the examination, sometimes in some question I have seen, they're asking with radix 5, they're asking with radix 3. So that are also possibilities is there. So be ready for this, how it is going to happen. Now here we'll take one example like how we are going to convert in that situation. Okay. So before that, let's discuss about how to convert octal to hexadecimal. Okay, all these things we are going to see. So this one you have seen that decimal you are trying to convert. So when radix value is lower, so finally number of digits are going to increase. So in case of when we are talking about octal or hexadecimal, so there we are seeing that number of digits are going to become less in compared to binary. Since they're having higher radix, radix is 8 or 16. Okay, so that is the benefit there. It's easy, okay, to read that with less number of the digits in compared to when we have more number of digits. So shorter patterns is easy to recognize when we have short patterns in compared to long pattern of ones and zeros. Okay, so now so this is like you have converted decimal number to different radix. So here we have seen only about the binary. If you want, we can see that one more about octal also. Okay. So in that, if you are taking 153 here, okay, radix is 10. And what will be its equivalent value in octal? So now again, what we have to do, radix is what here? 8. Okay, and number is given in the decimal number. Okay, and this number is what your integer. So it's easily we can convert this one into the octal. So what is the rule? That given integer should be divided by the radix. So what is the radix here? Radix is 8. So when we're dividing 153 by 8, so 1 time 8, here 7 is left, 7, 3. So 73, so 9 times 72. So, okay, so remainder is left 1. Quotient is 19. So again we'll divide by 8. So 8 how many times nearby 19? 2 times 16. Okay, remainder is 3. Now this quotient is smaller than 8. So further we can't divide. So this is going to be 2, 3, 1 with radix 8. We are writing from the bottom to top. Okay. Now suppose for example, if radix is not given, then we have to go for the hit and trial method by seeing that digits like here 1 2 3s are only available. So its radix is 4 or more than 4. We can start the hit and trial method by dividing 4. Since here this is the, what is the value? This is a LSB side, that is the first remainder. So like this, by dividing, we can check. If it is matching, we'll go for the next one. Okay. Otherwise, if you have only possibilities that we have three numbers only, then we can go for the quadratic equation also. Okay, that we'll see. Now, another conversion we are going to see here in the easy way, that conversion. Okay, we have here about first discussion about conversion from the binary to octal. So why we are choosing octal or hexadecimal? Since what is the reason for this? Shortened patterns is easy to recognize. So now binary to, we have to go for octal. Binary to octal. So here we are going to take one binary number. That binary number we need to convert into octal. So binary radix is 2. Octal radix is what? 8. Okay. So some numbers we are going to take for the example. So suppose some binary number is given 1, okay, 1, 0, 1, okay, 0, 1, 1, decimal we have triple 1, okay, and 1, 0, for example. This is given in the binary number that we have to convert into the octal number. So now if you see that in case of octal is what here? To the power 3 is the 8. Okay. So that's why here to the power 3 is going to become 8. So we are going to take the combination of 3 bits to obtain the binary to octal. Okay. Otherwise, you have to convert this binary number into decimal, and from decimal we'll get the octal. But direct method is there. Okay. So here what is the rule? From the decimal, this decimal is the reference point. From here left side we'll make the combination of 3 bits. Like here this is the first combination and we have another combination. If this combination is not fulfilled, we can add the 0 in the left side. Again, from decimal right side, we have one combination of 3 bits. Another combination is not possible, so we can add 1 0. Okay, here in the right side. The integer, left side, we can add the 0. This fraction, we can add 0 in the right side. So now this 101, what is the equivalent? Okay, 101 is what here? 5. 011 is what? 3. Now here triple one is what? 7. 100 is what? 4. So finally, this number in the octal is what? 53.74. Okay. So you'll see that how many digits were there in the binary. And here only for integer 2 digits. Again for fraction we have only 2 digits. This is the way how we can convert that given binary number into the octal. Similarly, we can convert from the octal to binary also. Okay, so logic is always combination of 3 bits in case of octal. So octal to binary. Now we'll take one number. Okay, for example, if you are going to take here, we have 63 decimal, we have 1, 2. Okay, so this value is what? Octal. Base is 8. So you know about the octal. Coefficient is 0 to 7. Okay. So your numbers will not be more than 7. So now for each octal digit, we are going to write with the help of 3 bits. Okay. So 6 is written as 110. 3 is written as 11, but we have to take 3 bits. So we'll write 0, 1, 1. Okay. After that decimal. 1 is written as in binary 1, but we have to take the 3 digits, so 0, 0, 1. 2 is written as 1, 0 in the binary, but we have to take 3 digits, so 0, 1, 0. So this is the binary equivalent of octal. Like we are able to convert binary to octal and octal to binary. In the same way, we are able to convert binary to hexadecimal again hexadecimal to binary. So binary to hexadecimal, and both vice versa is possible. Okay, that we can do here. Binary to hexadecimal. Okay. So now binary number will take, that will convert into hexadecimals. Hexadecimal is what? 16. The 16 is what? To the power 4. So that's why we take the combination of 4 bits here. And in hexadecimal, coefficients are 0 to 9. Again, A to F. So we'll take one binary numbers that easily we can write here. So for example, again here, same concept. If we are not able to make the combination of 4, we can add the 0. Like we have 1, 1, 0, and we have 1, 0, 1, 1. Decimal, we have 1, 1, 1, 1. And here, suppose we have 0, 0, 1. So now here we have to, this is the binary number, we have to convert into hexadecimal. So for this, we have to make the combination of 4 bits. Reference point is the decimal, okay? So combination of first 4 bits. Again, next combination is not possible, so we'll add here 0. Again here, combination of 4 bits. Next combination is not possible, so we'll add the 0. So now here, what is the equivalent? It is the 6. This is what 8 plus 3, 11. But 11 we don't write in the hexadecimal. So 11 is represented by B. Now this is what 15. 15 hexadecimal is what? F. 0010 is what? 2. Okay, so we'll write the 2. So finally in the hexadecimal, this is the 6B decimal F2. Okay, with radix 16. So this is how we have converted binary to hexa. Next we have hexa to binary. Okay. So you have to take care that in case of octal, combination of 3 bits. In case of hexa, combination of 4 bits. So now from the hexadecimal to binary, suppose we are going to write here some number. We have A6 decimal D. For example, this is in what? Hexadecimal. Now we'll try to convert into binary. So what is the rule? Each number will be written with the help of 4 bits. So A is what? 10. Okay, A is 10. So how will write 10? 8 plus 2, 10. So this is the 10. 6 is what? 110. But here what will write? 4 bits required. So we'll add 1 0. 0, 1, 1, 0. Decimal. D is how much? Okay, D is equivalent to what? Okay, so D is how much? 13. So what we'll write here? 13 in the binary. 8 plus 4, 12, and 1, 13. So now it's converted into binary. So like this, we are able to convert. Okay, if any confusion is there, so first you convert that number into decimal number. You know that how to convert the decimal number that we have seen here with the help of expansion. After decimal, if it is integer, divide. Okay, if it is fraction, multiply. This is how we are able to convert from the one number system to the another number system. So here we have binary to octal. So that already we have seen how we are able to convert binary to octals. So in the octal is what? To the power 3. So we are taking the combination of 3 bits. Hexadecimals, we are taking the combination of the 4 bits. Okay. This is the logic how we are able to convert binary to hexadecimal or octal, or from one number system to the another number system, we are able to convert. But if you have directly some particular numbers are given in decimal, then it will be easy. Okay. So some more example we can see, we can practice. Okay. So now in the exam, what they're going to ask, there is the unknown numbers, how we are able to find. So like we have seen earlier, okay, in that situation also we can work out for this. Example, suppose for example, we have 153 here. 153 base is what here? 10. And here this number is given 231. Radix is unknown. They're asking find the radix. Okay. So here you'll try to divide. If you divide this one with 4, what will get? 4 3 times 12. Again 32. So we have 33. So 8 4 times 32 will get carries in matching. So but what we are going to get next number here, whether for that we are going to get the same remainder. Okay, that we have to check. If it is we are not getting, like we have 153, we are trying to see that 4. Why we are trying for 4? Here maximum number is 3. Okay, so 4 can be the radix of this. So always coefficient are r minus 1, 0 to r minus 1. So r minus 1 here maximum is 3, so r can be 4. So dividing by 4, 4 3 times what we have? 12. 33, 8 times 32, remainder is 1. So it is matching with this one. So we can go for one more step. Again divide by 4. So 9 times what we have? 36. So remainder is 2. So this 2 is not matching what we have? 3. Okay, that means 4 is not the given radix. So like this, we'll try for 5. Again, we'll try for 6. Try for 7. Like this. Okay. So by observation, this one we know that it is the 8. So now we'll divide this one by 8. If we're dividing by 8, 1 time 8, 7. So 73, 9 times 72. 1 is the remainder. So this 1 is matching with the given LSB bits. Okay. So again, we'll divide by 8. So 8 2 times is what? 16. Remainder is 3. So what you're seeing here, we have 1, 3, 2. Here also 1, 3, 2. So this equivalent is what? 2, 3, 1, radix 8. So that means what is the x value for us now? This is going to be the 8. This is the one of the method how we are going to do here with the help of each and trial. And later we'll see that how to convert with the help of quadratic equation. Okay. So from any number system, how to go for the another number system. For the octal, you have to take the combination of 3 bits. For the hexadecimal, you have to take the combination of 4 bits. And higher order digits is easy to recognize. That is the shorter pattern is easy to recognize in compared to longer pattern. That's why we are going for the octal or hexadecimal. Okay, that is the one of the reason. So now if you try to see one example, we can see further here about we have 306 decimal D. It is given in the hexadecimal. We have to write its binary equivalent. So X we have to find, radix is 2. So it's easy. Now 3 will be written with the help of 4 digits. So 0, 0, 1, 1. 0 will be written with 4 digits. So 4, 0. 6 will be written with 4 digits. So 0, 1, 1, 0. Decimal D is what equivalent to 13. What will write? 1, 1, 0, 1. So this is what here, how we are able to convert hexadecimal into binary. Each digit of hexadecimal should be written with the help of 4 binary numbers. Similarly, you can see from this octal again, one more example from the octal to binary. If you have 673 decimal 124, this is the octal number. Radix is given 2, we have to find the numbers x. So here each octal number will be written with the help of 3 bits. So 6 is 110, 7 is the triple one, 1 is double one, so we'll write 011. Decimal 1 is 1, so 001 with 3 bits. 2 is 10, so 010. 4 is the 100. So this is going to be the binary equivalent of given octal number. So these are the different ways how we are able to find. Okay. Another, if you want, how we'll find that octal to binary or binary is given. Suppose 1, 0, 0, 0, 0 we have, and again we have 1, 1, 1. So this is the completely without fraction. This is the what is its octal equivalent. So decimal is where in the right side here. So we'll make the combination left side 3 bits combination, 3 bits combination. So here what we have to add the 0. So this is what here 2. This is the 0. This is what 7. So finally what we have 207 base 8. So octal we have to take care of 3 bits. In case of hexa we have to take care of 4 bits. Okay. This is how we are able to convert. Next we have how to find the radix. Already we have discussion, and here we see with the help of quadratic equation how we are going to find the radix. So any number, if you are going to expand with the radix, it is going to give us decimal equivalent. On the basis of that, we are going to write here, we have 23 decimal numbers. Okay. Now we are going to expand 212 with the radix. So here 0, 1, 2. So what we have, 2 is the digit into radix is r to the power 2 plus 1 into radix is 1. Radix is r, sorry, position is 1 plus again 2, radix is r, position is 0. So now try to simplify. 23 equal to how much? 2r square plus here what we have r, here what we have 2. So now this 23 will bring the right side. So 2r square plus r, we have plus 20 minus 23 equal to 0. So what we'll have here now? 2r square plus r minus 21 equal to 0. So this is what here quadratic equation ax square plus bx plus c equal to 0. So you know that in case of quadratic equation, if you are trying to factorize, we are writing p plus q and we are writing p into q. So p plus q is what here b, p into q is what here ac. Now we are trying to factorize product pq so that we can write at the sum or difference, so that we'll find the value of b. So on the basis of that, here what you'll see that in the given expression, what is the p plus q value? P plus value is what here? Going to be the 1. Okay. Whereas the P into Q value is what here? 2 into minus 21. So this one we have to factorize. So minus we can take in a starting into 2. Next we have 3 into 7. Okay. So finally this can be written as, okay, we have 7 into minus 6. So here if you do here for the P plus Q is what here? 1. So we can write 7 minus 6. Okay. So this expression can be written as 2r square plus 7r minus 6r minus 21 equal to 0. So just we have a small rearrangement so that we'll have better common term. So this minus 6r is taken here plus 7r minus 21 equal to 0. Now what is the common? 2r is the common. Okay. So r minus 3 plus 7 is common. So r minus 3 equal to 0. Now what is the common? R minus 3 is the common. So r minus 3, okay, into 2r plus 7 is going to be 0. So from this what we'll understand? Okay, either r is equal to 3 or r equal to minus 7 by 2. Okay, both we are equating to 0. But radix will not be fraction. Radix will not be negative. That means what is the radix here? R is 3. Hence R equal to 3. So this is what here? Number is what here? Radix is what here? R is what? 3. Okay. So this one you want to check. Suppose for example, without quadratic equation, what we can do? It is already given decimal number. So it's easy for you. If decimal number is not given, so that particular number system we have to convert into decimal. Like here octal is given. Then we have to convert this octal number into decimal number. Then we can do this process. Okay. And even division also, one part should be decimal number. That you be careful. Or sometimes binary is there, means again we have to hit and try. But if it is decimal, it's easy. Now if it is 23, it will divide this one with 3. Now we understood that radix will be 3. Or you can guess 2, 1, 2. Maximum number is digit is what here? 2. So its radix can be more than 3. 3 or more than 3. Okay. So always it is r minus 1 coefficients. 0 to r minus 1 are the coefficients. So radix is what here? Radix is always greater and equal to R. So if you divide by 3, what we have here, 7 times, okay, 21. So remainder is 2. Again, if you divide by 3, 3 2 times is 6, am I right? Remainder is 1. So now new quotient is less than 3. So this value is what here? 212. So 212, radix is 3. Okay. So sometimes they're asking 5 also, radix 5. So like this, how we are able to convert one number system into another number system. So here some already other lectures are also available with previous year questions and their solutions. Please go through that. And if you will have any doubt, write in the comment box. Okay. Thank you. Like, share, subscribe. Thank you very much.